Hello everyone, welcome back to the another lecture. So my name is Ashish and in this lecture we will see how to plot the power factor in the Matlab. So we have done so many simulations in regard with the power factor correction circuit, right? So I got a query that sir, how to plot the power factor in the Matlab. We know how to find out the THD, but if I wanted to plot, if I wanted to show someone that this is the nature of power factor throughout this simulation, so how I can show it, right? So for this I am making this video for you, and through this video I will demonstrate you that how we can plot the power factor. So let's get started with this video. This is a short video. I will quickly take you in a Matlab window, and there I will explain you this particular block diagram. What is this particular block diagram? I will explain you. Okay. So before going to the block diagram, I wanted to explain you the concept. Okay, you know this concept. The same concept we will implement. Let us denote the P as a active power, Q as a reactive power, and S as my apparent power. Right? You know this relation that S square is equal to P square plus Q square. Right? And my active power in one phase system I am talking about. So active power P is given by V into I into cos of phi, where this cos of phi denotes the power factor. So if I wanted to know that what is this V into I, this V into I is my apparent power. Okay, that is denoted by S. And if I wanted to write it down the power factor, so power factor from this particular expression, I can write down power factor as P divided by S. Okay, what is my S? S is basically under root of P square plus Q square. Same thing I am going to implement in the Matlab. Okay, so I will take my Vi from the reference and then I will use it. Okay, so I will quickly take you through the Matlab window and there I will demonstrate you the things. Okay, I hope so this concept is clear to you. Now I will just quickly take you. So this is the Matlab window. This simulation we have already done. This simulation is the totem pole PFC. Maybe if you are watching my playlist from the past, then you know that what is this all things and all, how to tune the controller for the totem pole PFC and all. Okay, now what is my input? Input is my V in, that is AC in nature, and this is my IL. This is again my input current. Okay, now I wanted to plot the power factor for this. So how to plot the power factor? So here I have put one block. So you just understand what is the meaning of this block. Okay, so let us see one by one. So I have taken my V in as a input voltage. This is I am taking from here my IL. IL is my input current. Okay, now I have my input current and input voltage available. Now I am passing it through one block. What is that block? This is a power block. If you just type here power, and this is a electrical specialized power system sensors. So if you type this, you will get this power block. Okay, so I have just taken the power block which will calculate the power for you. Okay, now I have taken the power block. Now what is the output of the power block? Output of the power block is P and Q. What is my P? P is my active power, Q is my reactive power. Now I am giving the two inputs, that is input voltage and input current. Now I am getting the two output, active power P and reactive power Q. Now what is the power factor formula? I have told you P divided by the power factor is what? P divided by under root of P square plus Q square. Now I am just doing the same thing here. I have taken P, I am using one math function U square. So if you write it down the square function, so you will get the square function. Okay, so I am just using that square function, and inside this you have so many functions. If you want square, if you want any different type of, so you will get all the functions here. Okay, similarly if you want square root sqrt, you write it down, you will get the sqrt. Okay, the same block I have used here. Okay, so this kind of block you will easily get. Okay, so I am doing the same thing. I have taken my P and I am squaring it. So I am getting here P square. Similarly I am taking my Q here and I am squaring it. I am getting here Q square. Okay, and I am taking under root of this. So what is the output expression here? Under root of p square plus q square. And from here, what expression I am getting? From here I am taking the p. So output of this particular block is my required power factor. And I can see here using the display, and I have put one scope here which will show me the waveform of how power factor is throughout this 0.5 cycle. Okay, so I will just simulate it once and I will show you. Okay, just I am running the simulation. So it is running. Just wait a minute, and within a minute we will come to know the nature of the power factor. So from the start only you can see that power factor is 0.999697. So that is in the display. Okay, so we have done this MATLAB simulation for totem pole PFC, you know that, and it is a good waveform. That time also we are coming. Okay, and the same thing now I am plotting here. So just so easily within very less cycle the power factor reaches to 0.999. Okay, so just I will open the scope and then I will show you how the nature of power factor is. So just it is opening, I will just show you. So other thing, you know, right? So you can see the waveform here that initially the power factor is fluctuating, but power factor is not fluctuating too much. It is nearby 0.98. If it is greater than 0.99, that is acceptable for us, right? So you can see here it is greater than 0.99 only throughout the cycle. So that is a quite good power factor. It is between 0.99 to 1. So the our circuit is following the IEEE standard, and our circuit is up to the mark, right? So this is how we can plot the power factor. I hope so you understood this concept. So I'm not running it completely, so you understood, I guess, that how to plot this. So with this this is a short video. I just wanted to tell you that how the power factor we can easily calculate. If we have the three-phase circuit, so same thing we can do. Okay, so three-phase power block is there, so you can use that block and you can easily calculate the power factor, and you can easily plot the power factor. So thanks for watching. So this is a short video. I hope you enjoy this, and let's see you in the another video. So thanks for watching.